Hello, this is Swapnil Dongre from IIPS DAV Indore. In this video, we will see the difference between the iterative methods on the basis of their iterative formula, their order of convergence, their evaluation of functions per iteration, and reliability of convergence. So first of all, I introduce you with the five iterative methods. First one is bisection method. Second one is false position method. Third one is Newton-Raphson's. Fourth one is secant, and the last one is successive approximation method. Um, the first difference between this method, iterative method, is on the basis of their iterative formula. Bisection method iterative formula includes xi plus 1 is equal to xi plus xi minus 1 divided by 2. This is a simple formula of bisection method where xi and xi minus 1 enclose the root. Second iterative formula for false position method is xi plus 1 is equal to xi minus 1 into fi minus xi into fi minus 1 divided by fi minus 1. Here also xi and xi minus 1 enclose the roots. But in the formula, it also includes the function at that point, that is xi and xi minus 1. The third one is Newton-Raphson, and its iterative formula is xi plus 1 is equal to xi minus f of xi divided by f of xi. The fourth one is secant method. Xi plus 1 is equal to xi minus 1 fi minus xi into fi minus 1 divided by fi minus 1. Here the formula of iterative formula of secant method is same as the formula of false position method, but here xi and xi minus 1 need not enclose the roots. In the false position method, we have seen that xi and xi minus 1 enclose the root, but in the secant method, it is not necessary that xi and xi minus 1 encloses the root. The fifth one is successive approximation method, that is iterative formula is xi is equal to g of xi minus 1, where g is a function of x. Now there is a second difference between this method on the basis of their order of convergence. The order of convergence. Bisection method, the order of convergence of bisection method is gain of 1 bit per iteration. There is a gain of 1 bit per iteration. Similarly, in the false position method, there is also gain of 1 bit per iteration. But in the Newton-Raphson method, there is a gain of 2 bit per iteration. Okay, and in the secant method, there is a gain of decimal gain, that is 1.62 gain per iteration, and in the last successive approximation there is a gain of 1 bit per iteration. Now evaluation of function per iteration means how many functions are evaluated per iteration. In the bisection method, only one function is evaluated per iteration. Similarly, in the false position also one function is evaluated per iteration. In Newton-Raphson, two functions are evaluated per iteration. Secant method also includes evaluation of one function per iteration, and successive approximation also includes evaluation of one function per iteration. Now there is also difference on the basis of reliability of convergence. Means the roots are obtained, means a guarantee over roots are obtained or not. In the bisection method, there is a guaranteed convergence, and it is sure shot that we'll receive the roots, we will have the roots. In false position method also there is a guaranteed convergence, that at the end of the iterative method there will be roots. But in the Newton-Raphson method, convergence fast if starting point near the root. In this, there is no guaranteed convergence, but convergence will be fast if starting point is near the root. Okay, but now next is the secant method. There is no guarantee of convergence if not near the root. I repeat, there is no guarantee of convergence if not near the root. You can see. And in last successive approximation method, no guarantee of convergence. It is directly mentioned in the successive approximation method that there is no guarantee of convergence. If you uses this, there is no guarantee of convergence, that you will get the roots at the end of this iterative method. So this is the following four characteristic on the basis of which we can make these five methods difference, the five iterative method difference. So I hope you understand this. Thank you.